Hello, can you hear me? Hello, there should be. So you got 11. Okay, people are joining. Okay, do you hear me? Is everybody here? You should see my desktop. Do you hear me okay?
Yeah, you sound good.
Okay, great. Thanks. Okay, so let's see. There's 17. Almost everybody's here. Okay, I'm just waiting. Okay, it looks like everyone's here pretty much now. Okay, so this is the graduate graphics class 51, was it 51580? Okay, so we're going to meet for the first couple weeks online using Zoom. Hopefully in 3 weeks we can get back to regular meeting on campus, but we'll do this for the first few weeks. Okay. You should see my desktop. Mostly what we're going to be doing in classes, I'll just be showing you examples of programs, and we'll be playing around with examining programs and utilities. And so, I mean, it actually works out pretty well. Showing you the desktop is pretty much exactly what I would be doing in a classroom anyway. Mostly I want to be able to look at code and run demos and just look at how things work on a computer. So you can pretty much see what I want to do by seeing my desktop instead of being at a projector in a classroom. So this should work out okay. Let's see, and let me check everything here. Okay, now first thing we're doing today is just go over the syllabus and a little bit about the course in general, and then we're going to start looking at just doing some real basic introductory graphic stuff using Java. Okay, so eventually the course will be about 3D computer graphics, but what we're going to start with is just real simple basic graphics with Java, doing 2D graphics and introductory GUI programming. I'll show you what I mean in a minute. So we'll be starting off with 2D graphics and GUI programming with Java, and then we'll go into using Java to do 3D graphics with OpenGL. Okay, so everything for the course is going to be on this course website. You'll use Brightspace for submitting homeworks only. So the only thing I really use Brightspace for is that's where you'll submit programming assignments. So all the material for the course will be here on the course website. Okay. All right. Now here is the syllabus for the course. Okay. There's no textbook for the course. We're just going to use online resources. I put some links to some. These are just some of the resources we'll use online. We'll just be getting different things from online as we go along. So I just put a couple links to some interesting websites here, but we'll use those and other ones too. And the course will be based on programming assignments. There'll be a program assigned every couple of weeks. You'll end up with probably like 5 or 6 programming assignments. So the course grade will be based on doing the programming assignments. Everybody's supposed to do their own programming assignment. Each person should turn in their own work. As it says in here, that means that what it means is you can talk to people in the class and you can discuss things about programming in class, but you shouldn't be giving people your programs, and you should not be getting programs from other people. And it's not legitimate to take somebody else's program and change variable names and submit it as your code. You should be writing your own code for these assignments. Okay, so the course will be based on writing graphics programs in Java. And the first assignment isn't up there yet. Like, here's the page where the homework assignments will be. There's no homework assignment up there yet. I started writing it up, but I haven't had time to finish writing it yet. So I hope it'll be up there in a couple days. Okay, and it'll be the first one will be a programming assignment, more or less on what we're talking about today, using Java to do basic graphics programming, 2D graphics programming. First assignment is going to be about graphics programming. The second assignment then will be about GUI programming. And I'll show you what I mean by that, but event-driven GUI programming, writing a program that responds to some kind of user events. Okay, so the first 2 programming assignments are going to be basic 2D graphics in Java. Hopefully by the third programming assignment, we'll start doing 3D graphic stuff. But first we have to get a sense of just what we mean by graphics. Okay, so Okay, so this is the syllabus. The main page here on the website is this page here, which is going to be what we're going to be doing every day. So there'll be an entry in here for every day that we meet. This is where you'll see reading assignments. There's a link here to the Zoom invite here. Then, for example, here's some reading assignments about what we're going to be talking about. Basic graphics. These are chapters that are online, like here. These are actually from older Java books. Java is a very good graphics programming environment, but nobody actually uses it anymore. Java has become the main tool for big data on servers, but it was originally designed to be a desktop GUI system. And it actually has a very, very good way of doing graphics, but the newer textbooks tend not to even mention it much. So these are chapters from some older textbooks that do a very good job of explaining. Here's another one. They do a very good job of explaining Java GUI programming and graphics programming. So these were introductory Java textbooks. These were actually very popular introductory Java textbooks. And for example, if you go get the current edition of these books, these chapters aren't even in them anymore. The chapters have been dropped from the textbooks. These are from older editions of the books. The current editions of the books don't have these chapters in them, but there's 3 of them here. Here's another one. Okay, and they're very well written chapters on introductory graph. Now this one's on graphics. These 2 are on GUIs, graphical user interface. So what we're going to do is we're going to start with GUIs and graphics, but see, this is graphics 2D. Okay, none of these books talk about 3D graphics. So there's nothing about 3D graphics in any of these chapters, but they're very good introductions to the basics of 2D graphics and GUI graphics. Okay, so I gave you any one of those I gave you links to 3 of these. Any one of them is a good reference to read. We're going to start off with a blend of this, both the 2D graphics stuff and the GUI stuff. And this chapter here, this one has both. It starts off with GUI programming, and then in about the middle of the chapter, it switches to 2-dimensional graphics. So this one reference here has both the introduction to GUI and introduction to 2D graphics. This one is only GUI stuff, and this one is only graphic stuff. Okay, it doesn't say anything about GUI. Now we'll see what the difference between GUI and graphics may not be clear yet. And that's one of the things we're going to explain. What do people mean by graphics programming? 2D graphics programming versus 3D graphics programming. What do they mean by GUI programming? You can do GUI programming without doing graphics programming, and you can do graphics programming without doing GUI programming. We're going to start off by doing a little bit of both, and we want to see what do we mean by the difference between these. Okay, all right. So that's a first reading assignment: is read any one of these 3. Probably the best one is this middle one here. This middle one here. This is the one that has both the GUI. It introduces the GUI stuff, and then after the first, there are a few sections on stuff on GUIs. Then there's a section on 2D computer graphics. Okay, so I think that's actually kind of a nice one because it does both. It introduces both topics. Okay, and there's a 4th reference here. This is the famous Java tutorial that's from the people who wrote Java. This is their 2D graphics tutorial. Okay, so this is the 2D graphics tutorial. They actually have a GUI tutorial. Let's see, how do you get to their GUI tutorial? Yeah, here's the GUI tutorial. It's pretty long. We'll occasionally we'll probably dip into it for a few things, but there's the tutorial on GUIs as opposed to the tutorial on 2D graphics. Okay, so the link here is to their 2D graphics tutorial. Now maybe I'll put a link to their GUI tutorial up there later. Okay, so again, people make a distinction between GUI programming and graphics programming. At the beginning of this course, I think we should learn what this distinction is, get a sense of what we mean by doing GUI programming, and then what we mean by doing graphics programming. And then the majority of the class will be about 3D graphics programming. So the course is really meant to be a course in 3D graphics programming. But first, let's figure out what. Yeah, it's important that you see something about GUI programming is important. It's a good thing to learn. Java is no longer the language for doing GUI programming. In fact, the GUI programming now would be HTML and JavaScript in the World Wide Web. That's the primary GUI interface that's in use these days is Java, HTML, cascading style sheets. But Java's GUI programming is a pretty good one to start with. Yeah, and since we're going to be doing 3D graphics programming with Java, it might as well just do the GUI program with Java too. We could do everything with JavaScript. We could do 3D graphics programming and GUI programming with JavaScript, but I'm not sure how well people are versed with JavaScript. I thought it would be safer to just stick with the Java language. So what we're doing is a little bit old-fashioned. Java GUI programming and Java, nobody actually does Java GUI programming anymore, and very few people do Java 3D programming anymore. They're very well, it's a very good system, it's very well designed, it's very well written, but it's not being used much anymore. Like I say, Java has become mostly a language for big data on servers right now. That's what that's what the vast majority of people writing Java code, that's what they're doing. And there's maybe a tiny number of people left who still do GUI programming with Java. Not too many. There's very few products anymore that are written. Well, a good example of it, there is one place where there is a fair amount of Java GUI programming, and that's on Android phones. And the Android operating system is like the last place where somebody might still be doing Java GUI programming. But even on an Android phone, they're probably more likely to use JavaScript, HTML, and cascading style sheets these days. But the Android operating system is based on Java. So originally, GUI programming on Android was done in Java. And I believe some still is. There's still a fair amount of it. But we're not going to do Android programming in a class like this either. That Android programming wouldn't be a convenient way to run a class like this. So good old-fashioned Java GUI programming from older books is going to be a good way to get our feet, to get a good introduction to Java, to graphics programming as a whole. Okay, all right. So now I didn't have time to put some links up to code up here. After class, I'll put some more links up here. I've got some code examples for us to look at, but I was writing them this morning, so I didn't have time to upload them. So let me show you some examples of simple introductory stuff about what we're talking about here. Okay, so here's a program. Let me just open it. A real short Java program. Okay, and I'll just compile it and run it. So I'll compile it and run it. Oops. Okay, here's what it did. It produced this little window up here. See, that program produced this little window, a graphics window. And it's actually got a button in it. And if you click the button, notice that you get something printed on the console window. So the program, this is a GUI program, not a graphics program. This is a GUI program. It created a window with a button in it. And when you click the button responds. Okay, let's look at the code real quick and see what we're talking about. Okay, in Java, a JFrame is a window. So Java is an object-oriented language, so everything is a class. So windows are represented by the JFrame class. When you create a new JFrame object, what's interesting is you're not creating a window. You're creating an object in the heap, but it represents a window. But you have to do a whole bunch of stuff to make that window actually visible. Now, let me switch from this. Right now I'm using TextPad. I'm going to switch to Dr. Java. Dr. Java is a tool we use for introductory Java programs, but it's actually got a nice thing. A nice feature. Let me close that and open Dr. Java. And I'll show you something there's something really clever about Dr. Java. So open this program in Dr. Java. Okay. Oh, and Dr. Java didn't start up. See that? I got this spinning. Every once in a while, Dr. Java starts up on my machine in a kind of a weird state. So let me close this and restart it. Dr. Java is an educational IDE. So it's a simple little IDE. So I can compile a program and I can run the program. See, and then if I click this button, see the console window is down here. Dr. Java embeds the console in itself. So there's where the outputs appear. Okay, now here's what I want to show you that's interesting about Dr. Java. Dr. Java has an interpreter for Java built into it. So right now, if I'm down here, I have a Java interpreter. So for example, I could say 3 plus 4 is 7. See, it's like Perl or Python or other languages. I don't have to compile Java code. I can just type Java code line at a time here, and it'll run my Java code as I type it. So for example, I can take this line of code here and copy and paste it down to here. Okay. Okay. Now I have to import. Just like up here, I have to import something before I can use the JFrame class. I have to do the same down there. So I'm going to go down here. Now I'm going to import. Then I can say, see, now I can create a JFrame out. Now I have got this object F. F is a window, a JFrame. It's actually an object in the heap. Where do I actually get a window? If I do f.setVisible, I call the setVisible method on that window. Whoops. Oh, I have to give it a parameter, setVisible true. Yeah, do you see it? It appeared up here. There's my window. This is my first step in GUI programming, getting a program to create a window. In that window, I want to draw graphics. I want to put buttons. I want to build. Also, that window is just like this window. This window is a JFrame, and this window is a JFrame. And for that matter, so is this window over here. All GUI windows are essentially these JFrames. Okay. Now, this is not written in Java. This is a Windows window. So this is written in C++. So this is sort of the C++ equivalent of a frame. But every window you get on your desktop comes from somebody instantiating a window object and then making it visible. Okay, now over here, here's my visible window. I could send messages to it. So for example, I could, f.set size 600, 600. See, or I could make it size small, make it 60 by 60. Notice I'm doing GUI programming. I'm sending messages now I'm sending messages to an object in the heap. But since that object's a very special kind of object, it's a GUI object, the Java virtual machine does more than just manipulate the object in the heap. The Java virtual machine asks the Windows operating system to draw representations of that object on my desktop. So it's a bit weird. It's an object-oriented programming language. Objects exist in the heap. They don't exist on your desktop. But when you start doing GUI programming, you get this notion that an object in the heap represents a GUI entity, but it's not Java that draws the GUI entity. It's actually the Windows operating system. The Java virtual machine has to communicate with the Windows operating system and ask it to draw on the desktop these things. Now I can send more messages, like for example, and notice that what's nice is over here is that in this interpreter, I can just I can talk to the GUI system. I can talk to the Java virtual machine by sending messages to objects. Okay. So for example, if I wanted to, I could create another frame. I'll call it F2. Wait, well, F2 is in the heap, but he's not visible yet. Oh, there he is. There's F2. Okay. So I've got two windows. Now I've got two GUI windows now that are independent of each other. I didn't give them titles. I didn't put anything in their title bar. Let's see. Oh, F2 dot set. I think it's set title. He was looking at the other example code. Yeah, set title. See, set title. So let me go down here and say F2 dot set title. He's F2. See, his title appeared up there. And let me give F1 a bigger title. Make something more readable. Oops. Oh, it was not F1, it's F. The first one is F. Okay. Okay, see, I gave him a title. I put a title in that window. Okay, so the nice thing about Dr. Java is it's got this interpreter built into it, and you can experiment with playing around with GUIs. Instead of having to write code, compile it, and run it, you can actually just do things directly with the objects, and you can watch them manipulate. You can watch them do things. Okay. Now let's go back to this one over here. Okay. Let me do something else. Let me create a button. Okay. So here is a button. Now I haven't imported button yet. So I just down here, it's the interpreter down here is very much like the compiler. It needs to be told that you're going to import things. So I'm going to go ahead now and import button down here. Then I use the up arrow key to re-execute the line that creates the button. Oh, now I got a button. Now, again, button B is just an object in the heap. Okay, it hasn't been put into either one of the GUIs. Okay, now F dot add B. I can add a button to the GUI. See, that was in this code right here. It was done right here. I'm going to do that now. I'm going to add the button to F. That's this one here. Oop, I was typing in the wrong window. Okay, so I'm going to. Okay. Now, but the button didn't show up here. The button's not there. I don't see the button here. I think I have to make, let's see. Let's see. F dot set. I'm not sure if the button will show up now. There, see, I had to make them invisible, then make them reappear. I had to redraw the window to get the button to show up. Sometimes the order that you do these operations makes a big difference. So I added the button to the window, but the button didn't show up until I made the window disappear, then reappear. So now there's a button there. Notice that the button doesn't do anything. Okay, I haven't programmed the button in any way. I've created a window and I put a button in the window. Okay, but I haven't made the button do anything yet. Now notice that the button took up the whole window. Okay, that's actually not very good. I mean, how many people, notice that this GUI window's got lots of buttons. There's buttons all over the place. Here's a button here, but you notice that buttons aren't supposed to fill up a whole window. Okay. Oh, I recompiled the program, so I lost my interactions. I shouldn't have done that. When you recompile over here, everything you did in the interactions is cleaned up. So I lost my windows over here. So if I go over here now, I have to re-execute everything. So for example, there, import JFrame, import button, create my there's my frame F. Here's F2. Okay, F dot set visible. Make F2 visible. Okay, there's one of them. Notice that they appear real small. If you don't set their size ahead of time, when they're created really tiny. Okay. Let me add the button. Okay, let me create the button. There's my button, and I'll add the button to F. Okay, the button's been added to F, but F was, oh, actually, let me give these guys names so I could see them. F dot, what was it? F dot set title. Okay, and F2. Notice that the titles appeared, but the button didn't. You know, so notice how the title appeared right away, but the button didn't appear. So now F dot set visible false, and F dot set visible true. There he is now with the button. Okay. Notice the funny thing is that the title will appear without having to do anything special, but the button, you need to make the window disappear, then reappear. There's a lot of weird details to GUI programming. That's one of the things that makes GUI programming kind of difficult sometimes, is that things you think will, the order of operations can matter a lot. Okay. So like adding a title to a window didn't matter what order I did it. I can make the window visible, then add the title. It didn't matter which order I did it in, but adding the button does matter. Okay, now the button doesn't do anything. Okay, now, and also remember, the button takes up the whole window, which is kind of weird. See, okay, now on this, I'm going to add a button to this one in a slightly different way. Okay, so I'm going to create a second button. Make this button 2, and it'll be hello. Okay, and now I don't want the button to fill up all of this window. So I'm going to do something to this window that's a little bit odd. Okay, I'm going to change the way this window, okay, a window is something called a container. The window contains GUI components. The button is called a GUI component. So in GUI programming, we have containers and components. Containers hold components. If you look over here, this is a container. It's holding all these buttons, and it's holding this text box here and a text box down here, and it's holding menus. These are all called components. So a menu is a component. A button is a component. A text field is a component. And these components are all sitting in this container. Okay. This container can only hold one component at a time. So when I put a button in it, the button filled up the whole container. What I'm going to do in this container is I'm going to tell it to hold more than one component. And I do that by giving the container something called a layout manager. A layout manager controls how components are laid out inside of the container. So what I'm going to do is I need to import a layout manager. Okay, so I'm going to import this thing called the border layout. And then I'm going to say, F2 dot, I think it's set layout. And I wanted to give it a new border layout object. Now this is kind of odd. This takes a little get weird. I create something called I create a border layout object. Okay, and I give a reference to that border layout object to this window object. I think I did the right command. I think it's set layout. Well, let's just try it. Okay, that worked. Okay. Now this guy has a border layout. A border layout divides this window into 5 regions: a north region, a south region, an east region, a west region, and a center region. Okay, and let me show you a picture of that. Here's a website, a visual guide to layout managers. Here's what the border layout manager looks like. A border layout has 1, 2, 3, 4, 5 regions in it. Each region now holds 1 component. Originally, my window had no layout manager, so the window held 1 component, and the component filled up the whole window. Now I've given my container a border layout, and it can hold 1, 2, 3, 4, 5 components. Each component will now fill up the region. Okay, so now what I'm going to do over here is I'm going to put my button in the south. Okay, so now I'll do F2 dot add button 2, and I say border layout dot south. This is saying add B2 to F2 in the southern part of the border layout. That would be adding it to this bottom part down here. The southern. This is called the north, the south, the west, east, and center. Okay. So the button should now, let's see, here's the second window. Okay, now I think I need to make it invisible again, because remember we need, oh no, there it appeared. I just resized it. Okay, now my button doesn't do anything yet, but my button is in the south. It's in the south. It didn't fill up the whole window. It didn't fill up the whole window. It filled up just this southern part of it. Okay, now this is GUI programming. I'm building a GUI. Notice that that's a lot better than what I had over here. Here, I'm not really building much of a GUI. My button takes up the entire window, which makes it impossible to do anything GUI-wise. Here now I have the potential that, okay, I've got a button on the south. I could put a button over here or something over here. For example, I'll put a label in the north. Okay, so I'm going to import java.swing JLabel. Now, JLabel is another component. Whoops. Oh, Java X. JLabel is a component. It's a component that just lets you put a label inside of a GUI. It's part of Java's Swing package. Notice that if you look at these imports, I just imported something from Java Swing. The border layout was imported from Java AWT, which stands for Abstract Windowing Toolkit. And this is part of the messiness of this. Over the years, Java's accrued a whole bunch of graphics libraries, and some pieces are in one graphics library, and some pieces are in another graphics library, and some pieces are in some other graphics library. And you end up importing from all kinds of different places. Okay, and this is part of what the documentation tells you, like where do you import these things from? One way to do that is if you go over here and you say Java 11 JLabel. Google will find the Java doc for JLabel. And then you can see it's in the package javax.swing. So you import JLabel from javax.swing.jlabel. So the Java doc will tell you where to import from. Okay. So a lot of times I never remember where these things are. So if I want to use a J button or a J label or a border layout, I just Google it. So for example, Java 11 border layout. Java, okay, border layout is in the AWT package, not the swing package. And notice it's java.awt, but it's javax.swing. You really have to wonder why these people drive you nuts with these kinds of weird naming conventions. Why did it go from javax.awt, from java.awt to javax.swing? Why isn't it java.swing? Why is there a swing in an AWT? Why is there a java.awt, a javax.swing? This is the details you have to keep looking up. When you're doing this kind of style of programming, you just keep looking these things up because it's unless you do it all the time, it's really hard to remember these things. Okay, so now I'm going to add something to the up here. I'm going to add a label up there. So I've got my label imported. Okay, so I'm going to say f2.add new JLabel with okay, that'll be what's the label. A label is an inert thing. A label is a component that just holds a string. Let's see, did I spell? Let's see. Oh, and then I have to say I want to put it in the border layout dot north. Oops. Oh. Oh, did I misspell that? No. Let me see. What did I do? What did I type wrong? Did I? Oh, oh, I'm missing a parentheses. No.
I think JLabel.
Pardon me?
You spelled JLabel as JLABEL.
Oh, yeah, I've got an extra L in there. Yeah, I've got an extra L in there. There. Okay, thanks. Yeah, I had an extra L in there. Okay, let's see. Now go over here, resize it. That makes it redraw. There's the label. Okay, so I've got a label in the northern region of the where's that picture? I forgot where my picture of the border layout was. Let's see. Make this go away. Oh, yeah. Okay, so there's the border. I've got something in the northern region and something in the southern region. Okay, so I'm building a GUI. Yeah, I'm writing code, lines of code that build up a GUI. And I'm doing it in this case in an interpreter so I can see what each line of code does individually. So I just added a label to the northern region of this thing with the border layout. Okay, button down here, label up here. The west region and the east region are empty and the center region is empty. I don't have anything in I don't have anything in this region, or this region right now in this GUI here. I just have something in the north and the south. Okay. Now, notice that the border layout only lets you have 1, 2, 3, 4, 5 items. How in the world are you going to build a complicated GUI like this if you only have 5 regions? What you do is you nest containers inside of containers. So, for example, to build a really complicated GUI like this, I'll show you what I mean by that. I'm going to put another container inside of this container. Like right now, this container can only hold 5 components. 1, 2, 3, 4, 5 components. What I'm going to do is I'm going to give the center component its own border layout. Then I'll have 9 regions in my thing here, because I'll have the 4 regions of this border, but then this inner border will have, the center part will have 5 regions. Okay, so let's see if I can do that. Let me try doing that. Okay, so I'll go here. What I want to do is, well, actually, I'm sorry. Here's how I'm going to do that. I cannot give, I'm sorry. I can't give this thing a border layout. You can't give that thing a border layout. What that thing does is it's a region that holds containers and components. So what I'm going to do is I'm going to build a container with the border layout and then add it to this region here. So here's how I do that. If you want a window to hold a container, the container you put in a window is called a panel. Okay, so panels are containers that sit inside of other containers. So we have nested containers. So I'm going to import, it's right here. I'm going to import something called a J panel. Okay, so well, whoops. Okay, so now I'm going to create a J panel. And I'm going to give it a border layout. Now, notice I've got 2 constructors there. I'm constructing a panel, and I'm telling the panel to be constructed with a border layout object in it. So I'm constructing a panel, and that panel is going to hold a reference to a border layout object. So I've got a panel object holding a layout object. Okay, whoops. Oh, misspelled it. Okay, now that panel can't be made visible by itself. The panel's not an object that can be made visible. This is a window. It's a JFrame. It's what we call a top-level container. Panels are sub-level containers. They're nested containers. The only way a panel can be visible if it's put inside of a visible thing. So what I'm going to do is I'm going to add that panel to the center of this guy here. So I'm going to say my frame2.add. I'm going to add my panel to border center. Oops. Okay. So the panel has a border layout. The panel's being added to the center of this guy who has a border layout. Okay, let's see if that worked. Oh, it was oh, J for J panel. Yeah. Okay. Now we don't really see it because the panel doesn't hold anything. The panel's not holding anything. Okay. But now I can add things to the panel. Okay. So j.add new JLabel. And I'm going to add that. Now I'm adding this to the, remember the J panel's in the center of the JFrame. I'm going to add this to, say, the west part of it. So I'll okay. So now I'm adding that to the J panel, and the J panel sitting inside of the JFrame. Oops. Oh, forgot to capitalize the L. Okay. There. See, there's the west. Now that's the west part of the JFrame, of the J panel. Frame 2 dot add. Wait, okay. Now I'm going to add something to the west end of the, see, 2 is on the west end of, 2 is on the west end of this border layout. 1 is on the west end of the border layout on the center panel. The center panel's got a border layout and it's got 1 on its west end. And let me put something on its east end. Okay, there's the panel. I'll add 3 to the east. Okay, and I'll add 4 to the west of the frame. Well, I'm sorry, I meant to add that to the east. Okay, see, this is GUI programming. I'm building a GUI, okay? I'm building something that eventually I could build something like this. It takes hundreds of lines of code to build something like this. Yeah, if you actually looked at the source code, there probably literally are hundreds of lines of code to build up this complicated GUI. Because what somebody has to do is, for example, see this row of buttons. Well, they have to create a container to hold the row of buttons. Then they have to add each button to the container of the row of that container. Then they have to add that container to some panel that represents a region of this window here. You have to build these GUIs up slowly, line by line. It's actually pretty complicated types. It's a very complicated style of programming, but this is very traditional GUI style programming. I'm I'm putting containers inside of containers so I can build up like here's an example. How do you get this? This is something called the box layout. Okay, it lets you put things in rows. Okay, you could put that layout in the center here. So you could put this kind of layout inside of this center here, or you could put this kind of layout over here. There's another kind of layout that lets you put things in this thing lets you put things in a column. This thing lets you put things in a row. Okay, there's a whole bunch of different layouts. Depending on whether you want to put things in rows, columns, grids, if you want, you can group things. Okay, so this is one aspect of GUI programming. You have top level containers that are the windows you see on your desktop. you put into the top level containers panels that let you group things, and then you put layout managers in the panels, and then you can put components in the layout, in the inside the regions of the layout manager. Okay, so now this is not graphics programming. This is GUI programming. Somebody else has designed what these buttons and these labels and all these windows look like. I'm not actually doing graphics. This is kind of like Legos. I'm just snapping these things together. I'm just saying, add a button here, add a text box here, add a label there. Let me add one more kind of component to this thing. One kind of component is let's see. Here it is, JTextField. Okay, so now I can add a text field to something. So let's see. Let's add it to the center of the I'm going to add a JText field to the center of the J panel that's at the center of the border of the window. Okay. Okay. So this is a big text panel. See, I can type in here now. So now I've got a text panel. Notice that it's one line of, if I keep, it's actually one line of text. See, it doesn't wrap. Now, why does it appear so big? Is because it's stretched out over, it's stretched out over the entire center region of a border layout. It's one line of text. A text field is one line of text. So in this GUI here, like, let's see. Oh, is there a text field somewhere in this GUI? It doesn't look like there is. Oh, a good example of a text field would be this. See, there's one line of text. There's a text field. I can type anything I want in here. Okay, that's a text field. Text field is just one line of text. Okay, but over here, I've done a really bad job of laying out my GUI. So my text field is stretched out over the whole center region of this panel. So it looks real weird. You know, if I want to do this nicely, I should make sure that the thing I'm putting the text field in is just about the right height. But the way these components work is they fill up. Any one of these regions can only hold one component. So when you put a component in it, it fills up the whole region. Normally, you would put a subcontainer inside one of these things and then put your components into pieces of the subcontainer. I put the text field into a whole center section, and so it took up the whole center section. Okay, all right. Now, this is one aspect of GUI programming, laying out the GUI. That's why I'm using layout managers. I'm making how the GUI looks. And this is a pretty ugly GUI, but I'm making how the GUI looks. The other thing is I want the GUI to do things. So let's back up a little bit and let's just look real quick at an example of making the GUI do something. Okay. Oh, just a second. How much time do we have left? I lost my timer. I had a timer set up. I think I accidentally closed it. How much time do we have? Let's see, what time do we end? 4:45, right? Yeah, so we got 15 minutes. Okay. Now, let's go back. I'm going to close these windows. Let's go back to our let's see. go back to this program here. Okay, this is the one that had the button. See if I compile this. Oh, I'm sorry. Oh, let me close these for now. Compile. Okay, remember this one, when you click, you saw something down here. So this is a button. It fills up the whole GUI, but the button does something. Okay, how does that work? Okay, that's this one line of code here. Okay, this is kind of a, look how long this line of code is. This is, let me break this line of code up a little bit to make it a little bit easier to read. This is actually a very long, complex line of code called an event handler. Okay, so there's kind of laying it out a slightly different way, make it a little bit easier to read. Okay, when I click on this button, I want something to happen. Something happens when you call a function. You make, programs do things by calling functions. So what I'm saying is that when I click this button, I want some function to be called. Telling a graphic system to call a function when something happens is called event handling. So here's how this works. My button, I'm going to add to the button somebody that's listening for actions. Okay. So in a sense, there's a function. Now here's the function here. See, there's a function. It's a void function, doesn't return anything. It's called action performed. It takes in a parameter called E. Okay, and all it does is it prints out ouch. Now printing here happens down here. So system.out.print happens down here. Whenever this function gets called, you see ouch down here. Okay, now, but when is this function called? Well, I never call it. If you notice that this function is called action performed, there's no calling of that function in my code. What happens here? When I call this function, I tell the button to, I'm essentially saying to the button, when you're pressed, you call this function. The button calls this function, not me. My code doesn't call this function. My code tells the button code that when the button gets pressed, that the button should call this function. This is where we spend a lot of time on this. This is called event-driven programming. Okay. This is a big part of modern GUI programming. It's part of Java. It's sometimes also called asynchronous programming. A lot of times people don't refer to it as event-driven programming anymore. They refer to it as asynchronous programming, because here's my function. The asynchronous notion is that my function's called not by me. It's not synchronized with any of my code. It's just that whenever the user feels like clicking over here, then my function gets called. Okay, so it's not synchronized with my code. It's synchronized with what somebody else does over here. So some people refer to it as asynchronous, unsynchronized function calls. Okay, the better term is just event-driven. When an event happens over here, this thing gets called. Okay, all right. So now that was actually, no, this is actually one line of code. This is really strange, because what it's doing is saying to the button, add something. So I'm calling the add action listener method on the button. Okay. Then what I'm doing is I'm instantiating an object. See, I'm saying new object. Then that object holds the method. Okay. So I'm adding to this button an action listener that is this object. So I'm calling a constructor. I'm calling a method that adds this constructed object, and this object holds a method. It's really abstract. It's going to take us a little while to get our heads wrapped around. If you've never seen anything like this before, it takes a little while to get used to this kind of style of programming. But I'm telling the button to add to himself an object. That object holds a method. And what the button does is that when the button is pressed on, the button calls that method inside that object. Okay. Right. And I can have this method do anything I want. Right now, it's just doing something dumb. It's printing something over here. If I wanted to, I can change that to ouch, ouch. Then if I recompile this and run it, now see, I changed what it does. Now, eventually you'd like it to do something tied to the GUI itself. Usually when you press a button in a GUI, it does something inside the GUI. It doesn't print out something to the console window. Okay, but right now this is just a really trivial example. But I click on something in the GUI and the GUI just prints something out to the console. Most GUI programs don't even have a console window. In this case, I have a GUI program with a console window. That's usually not, most GUI programs don't come with any console at all, so you wouldn't see something like printing out ouch to it. One thing that's interesting is I told you the modern GUI nowadays is the web browser. There is a GUI console. If I type F12 and I click on console, there's my GUI console. This GUI actually does come with a console, and if I wanted to, I could have what's going on in this GUI print things to this console. This console window here is exactly like this console window down here in Dr. Java. Okay, this console window is built into Dr. Java. This console window is built into the browser, and it's a real console window. It knows how to evaluate things. See, 5 + 6 is 11. It's a JavaScript interpreter. This console is a Java interpreter. This thing's interpreting Java. This thing's interpreting JavaScript. But this console window's built into the, which is nice. It's nice that browsers have a console window built into them. Now, most GUI programs that you run on your desktop, like there's no console window that goes with this program. This console window goes with the tabs running inside of this console window. Is a console window for the JavaScript running in here. This program was written in C++. The browser is written in C++. There's no console window for the browser, but there is a console window for the JavaScript running inside of the browser. But that's kind of an interesting thing that you can interact with your GUI programs. When your GUI programs are written in JavaScript and HTML, you can interact with them over here, just like I'm interacting with these programs over here by, I can type things into this console window and see things in effect and do things to this GUI if I wanted to. Okay. All right. Now, let's look at some of the other examples. I'll put these examples up on the course website after class. Okay, I have a folder with several different examples in it. Okay, so let's just look real quickly at some of the other examples. This is the one we just did. Okay. Here's another example that just a slightly more elaborate version of what we just looked at. Oops. Clicked on the wrong button. Okay, so there's a program that built up a more elaborate GUI. So I'm using a border layout. I have hello, a button down here, a button up here. I've got a label on the east and a label on the west, a label on the east, and in the center I put another row of buttons. So I have now none of these buttons do anything, but I've got in this border layout I've got a button in the top, a button button in the north, a button in the south, a label in the west, a label in the east, and then I put a panel in the center. And in the panel, I gave it a row layout. And in that panel is 2 buttons, 2 labels, and another button. Okay. So if you go look at the code, you can see it built all those up step by step by step. There's the outer window, the JFrame. Okay. Then there's one button. There's two buttons. Let's see, which one are those? Those are the buttons that are going to end up in the north and the south. So those two buttons are going to end up in the north and south eventually. Okay. I give this guy the border layout. Oh, see here, I added B1 to the south. I added B2 to the north. Okay. Okay. Then I created a couple labels, label 1 and label 2. I added them to the east and west. So up to this point, I've got the button up here, the button down here, the label over here, and the label over here. Okay. Then I set the size to 600. Okay. Then I create a panel. This is the panel that's going to sit in the middle part and hold these buttons. So there's the panel. Then I create two more buttons, hello 3 and hello 4. I create two more labels, label 3 and label 4. And then oh, this is the board. I thought I had a different layout. Oh, this is in the east, west. Oh, let's see. It's not laid out the way I expected it to. Oh, I'm sorry. It's using the flow layout. Yeah, right now it's using the flow layout. If I'll close this and change it to the border layout. The flow layout puts these things in a row. Then if I comment out this and uncomment this, it'll change the layout. Oh, what did I do? Oh, my keyboard's broken, so I'm having trouble with the keyboard. Okay, see now, completely different looking layout. Notice the difference between it being actually, I think I can put them both up here. So let me go back to the other one. Okay, see the difference in layout. By changing that one line of code, by changing from a flow layout, the flow layout is a default layout. So here I create a panel with a default layout, and then here I created the panel with a border layout. And you can see it looks quite a bit different. This one's got a flow layout, the default layout, and this one's got a border layout. So this is a border layout inside of a border layout. Okay, so one difference in the line of code makes a huge difference in the appearance of these programs. Okay, all right. So there's an example of more GUI programming. Okay, now time for one more example. Let's look at a real quick example of a graphics program. Okay, let me compile and run it. By a graphics program, I mean starting to draw things. Like this case, I draw two rectangles. Now, these aren't components. They're not buttons and labels and checkboxes. These are drawings. And it means I could draw circles and triangles and lines and points. This is the difference between GUI programming and graphics programming. In GUI programming, I work with components and containers. And I add components like buttons, labels, checkboxes, text boxes. I add components to a window. In graphics programming, I essentially have a blank slate and I draw on the blank slate. In this case, I drew two rectangles. Okay. See here's how this works. I start with a frame. Everything always starts with a frame. Okay. Then I create a panel. just like before. But now, instead of adding components to that panel, I draw on the panel. What I do is I'm going to actually subclass something called the J panel. Before we added J panels, if we look at these example here, notice that we see how we added a J panel with the flow layout, or we added a J panel with the border layout. In this example, I'm doing something subtly different. I'm making a subclass of panel. And what I'm doing is I'm going to make this subclass of panel be a panel that draws on itself. And what you do is you give that class you override the paint method. So I'm going to extend the J panel. In fact, I should put here that I'm overriding. Okay, so I'm overriding the paint method, the paint component method in, see, I'm overriding the paint component method in the J panel class. And what the paint component method does is it gets what's called a graphics context, and then it draws graphics on it. So I can set the color to red. This is called fill rectangle. This is the upper left-hand corner of the rectangle and the dimensions of the rectangle. So it drew a rectangle. That one's this one in red, or that one's this one in red. Then another one in blue. Okay. If I wanted to, I can add a green one. And I could make it say, move it over a lot, say 300. 300. So that's moving it over to the right and down. This is the XY coordinates. Now I'm using coordinates. I'm switching to graphics. Now I'm using coordinates on this plane. Origin is up here in the upper left-hand corner. That's 0, 0. So I'm going 300 pixels over, 300 pixels down, and I'm going to draw a 100 by 100 box, a green box. Okay, so there's my green box that's 300 pixels over, 300 pixels down. That's my upper left-hand corner. 300 pixels over, 300 pixels down, and then I'm drawing a box that's 100 by 100 pixels. Now notice in GUI programming, I don't use coordinates, I use components. And when you take a button, you put it in a region. When you do GUI programming, you just say add a button into the east region or add a button to the north region. You don't use coordinates like where you want something to be. When you do graphics programming, instead of having a container with regions, you essentially just have a flat drawing surface, and you can draw in that surface anything you want. Notice how, see how that thing disappears because it's at 300 by 300. It disappears when I go like this. When you do the GUI programming acts very differently. Remember, like, go run this again. See how they shrink with things. See how the thing shrinks all the components are still visible because they keep readjusting themselves to fit in the GUI. See, this is real interesting. The GUI programming readjusts itself in the layout. The layout manager is doing that. When I do graphics programming, if my window shrinks and my graphics is out of the range of the coordinate system, it just doesn't show up anymore. So in the graphics programming, I have a coordinate system. If I draw outside of that coordinate system, it's just lost. Okay. So the graphics programming is coordinate based. I have an XY plane. X goes this way, positive X goes to the right, positive Y goes down. The origin is in the upper left-hand corner. And I have points in the plane. The points are called pixels. And I can do anything I want pixel-wise. I can paint any pixel I want in this window. Okay, so that's GUI program, or that's graphics programming. This is GUI programming. This is graphics programming, and you can get, they're very different. They're both drawing on windows, but in very different ways. The point of graphics programming is to draw graphics. The point of GUI programming is to get programs that people can click on and get programs to do things. The point here is to get these buttons to do things. The point over here is to draw some picture that somebody might like. Okay. All right. So we run out of time. I'm going to put these examples up on the course website. All these little examples, these little baby programs, I'm going to put them up on the course website. I'll put this folder up there, and you can play around with these examples. And what I've just did is real quickly, we just gone over a lot of what's in these reading assignments. We've just very quickly see buttons, action listeners, container classes, panels. We've just gone over much of what's in these chapters in these books real quickly. We've just done a real quick overview of a lot of what they point out in these things. There's a lot of devil in these details. There's actually writing real GUI programs is very hard to do. What we're going to do is just get a sense of what it is. We're really not going to spend a whole lot of time learning how to do it. People spend years and years and years learning how to write real GUI programs. Like I say, a GUI like Dr. Java or Chrome, just even something simple like Dr. Java, laying out the GUI of that is just going to be hundreds and hundreds and hundreds of lines of code, not trivial code stuff. Okay, so anybody got any question? Any last minute question? And I recorded this. I recorded the lecture, so I'll put a link to the recording after. It'll take me a little while to get it up there, but after class, I'll put a link to the recording of this, and I'll put a zip file containing the code examples we did, and you can play around with them. Okay. And if you have any questions about this kind of stuff, if you have any questions from the readings, just please let me know. Okay. All right. Any last question at all? Okay, so I'm going to just stop sharing, and I'll close the class, and look for the video and these code examples up there in a little bit of while. Okay, bye bye.